Hi, let's begin. Important questions on arithmetic progression, part 1. Our first question number 1. Which term of the sequence 72, 70, 68, is 40? So here we have 72, 70, 68, dot. Now, first of all, we are sure that this is an AP because the difference of a term and its preceding term is same throughout. So what is the difference over here? It is minus 2, isn't this? So we know we consider the first term as A. So here the first term is 72. How much is difference? Common difference? It is 70 minus 72, which is equal to minus 2, isn't this? Now we need to find out what is the position of this 40, which term is 40. Since we don't know, we can suppose let Tn equal to 40. It means nth term is 40. You can suppose this Tn as An as well, no problem. So we have supposed Tn is equal to 40. We need to find the value of n, the position of 40, isn't this? So we know Tn is given by a plus n minus 1 d equal to 40, or we are provided a means first term. The first term is provided as 72. So 72 plus n. Is n known to us? No, n is not known to us. So n as it is minus 1 d. D means common difference. Common difference just we have calculated. It is minus 2. So let's put minus 2 over here. Minus 2 is equal to 40. Now let's solve it for n, or it is 72 minus 2n plus 2 is equal to 40, isn't this? Now you please solve it to find the value of n, which will ultimately come as 17. It means the position of 40 is 17th term, means T17 is 40. So 40 comes in 17th place. Is this clear? Okay, now let's go to next question. Question number 2. Is 68 a term of the AP 7, 10, 13, dot. So here our AP is 7, 10, 13 and so on. We need to find out whether this 68 is also a part of this AP or not. So we need to find 68 is a part of this AP or not. Just check over here. 7 is the first term. 10 is the second term. 13 is the third term. And so on. Fourth term, fifth term, sixth term will come. The position of all these terms 7, 10, 13 and whatever number will come next is given by the natural number. Is 1, 2, 3 and then will come fourth term, then will come fifth, sixth, seventh. These numbers 1, 2, 3, 4, 5 and so on, they all are natural numbers. So the position of the term of an AP is given by natural number. So if 68 is the term of this AP, then its position must be also given by a natural number. So we'll suppose the position of the 68 be nth term, means we'll consider let nth term be 68. If in fact 68 is the term of this AP, then the value of n must come a natural number. If the value of n does not come a natural number, then 68 does not belong to this AP. Is this clear? Okay, then let's continue. So we have here the first term. First term A is 7. How much is difference? Difference is 10 minus 7, that is equal to 3. Isn't this? Now we'll suppose let Tn be 68. Is this clear? That is Tn is equal to 68. Now let's put the formula of Tn. We know the formula for Tn is A plus n minus 1 d. And right hand side 68 is copied. Or A, the first term is known to us, 7 plus n, we need to calculate n minus 1 d. Is d known to us? Of course, it is 3 equal to 68. Isn't this? Now let's simplify this one. Or 7 plus 3n minus 3 is equal to 68. Isn't this? Or it is 4. 7 minus 3 is 4. 4 plus 3n is equal to 68. Or it is 3n equal to 68 minus 4. Or 3n is equal to 64. Therefore, n is equal to 64 over 3. Is 64 over 3 a natural number? No, it is not a natural number. It is not a natural number. Is this clear? Since n is not a natural number, the term 68 does not belong to the given AP. So, since n is not a natural number, the term 68 does not belong to the given AP. I hope this is clear. Now let's go to next question. Question number 3. How many natural numbers are there between 200 and 500 which are divisible by 7? So we are given a number 200 and 500. But question has said between. So between means we cannot include 200 and 500. But whatever comes in between 200 and 500 can be taken. So the first number that can be taken is 201. Then 202. Then 203. So on till 499. Isn't that? 500 cannot be taken, but 499 can be taken. Similarly, 498 can be taken. 497 can also be taken. So in this way, we'll come forward. But question has said, how many natural numbers between 200 and 500 divisible by 7? Is 201 divisible by 7? No. Is 202 divisible by 7? No. Is 203 divisible by 7? Of course, 203 is divisible by 7. So we can take this number. So what is the next number after 203 which is divisible by 7? Is it 204? No. So if you keep on calculating, you will find that the next number which is divisible by 7 is 210. Is this clear? Now what is the next number which is divisible by 7? It is 217. Isn't this? You can simply get a next number by adding 7 to the previous number. Like here is 203. When we add 7 to this number, we are getting 210. So when we add 7 to this 210, we are getting 217. So in this way, we can get the numbers which are divisible by 7. Now, if we keep on continuing, we should check till 499. Isn't that? So let's begin from 499, which is at last. Is 499 divisible by 7? No. Is 498 divisible by 7? No. Is 497 divisible by 7? Yes, 497 is divisible by 7. So in this manner, if we keep on going, at last we are going to find out 497. Isn't this? Now may I know a number which is before 497 and which is divisible by 7? It is 490. What is the number before 490? It is 483. So how am I getting these numbers? Just I need to find the last number and subtract 7 from the last number. For example, from 497, if I subtract 7, I am getting 490. And from 490, if I subtract 7, I get 483 and so on. Isn't this? So ultimately, we have got numbers 203, 210, 217, so on. Then it is 483, 490, 497. Don't you think this sequence of the numbers will form an AP? Of course, the difference between two terms, a term and its preceding term, is same throughout. Here the difference is coming 7. So we can write here this will form an AP where A, the first term, is equal to 203. Common difference D is 210 minus 203, which is equal to 7. Now we need to find out the number of terms. So let's consider the last term. What is the last term? It is 497. So let 497 be Tn. So Tn is equal to 497. We have supposed. Let. Then we know Tn is given by a formula A plus n minus 1 d. Or let's input the value. Tn is 497 as per our supposition. A is 203 plus n is not known, so n minus 1 is copied and d is 7. Or it is 497 minus 203 equal to 7n minus 7. Isn't this? Or 294 equal to 7n minus 7, or 294 plus 7 is equal to 7n. Isn't this? So ultimately we are with 301 equal to number 4, 7n. How many two-digit numbers are divisible by 3? So what is the first two-digit number? And it is 7. First two-digit number is and 10. 7. Next is 3 11. Are then 21, 12, then so 13, and so on out to be 43. Isn't this? The last, it means there are digit number. So what is the last 2-digit number? Therefore, it is 99. Number before 99 comes 98. Terms before 98 comes is equal to 97. 43. Isn't this? I hope you got in this way. The 2-digit number begins from 10 and the last 2-digit number is 99. But in our question it has said 2-digit numbers which are divisible by 3. So is 10 divisible by 3? No. 11? No. Is 12 divisible by 3? Yes. So 12 should be taken. Then is 13 divisible by 3? No. Then comes 14. Is 14 divisible by 3? No. Then comes 15. Is 15 divisible by 3? Yes. So 15 must be taken. Then what is the next number to be taken? 18. Isn't this? So how to get these numbers? The easiest way is, first of all, get the first number, that is 12. Then keep on adding 3. 12 plus 3 is 15. 15 plus 3 is 18. And so on. Again, at last, the number is 99. Is 99 divisible by 3? Of course, 99 is divisible by 3. So we should take 99 as well. What is a number before 99 which is divisible by 3? It is 96. You can try it. And before 96 comes 93. Again, how to get these numbers from last? First of all, you need to get the last number. Then just subtract 3 from the last number. Here 99 minus 3 is 96. And 96 minus 3 is 93. And so on. I hope you got this one. So these numbers, if we look carefully, they will form an AP. Isn't this? So these above numbers form an AP. So these above numbers will form an AP where the first term A is 12, common difference D is 15 minus 12, that is 3. Now we need to find out how many 2-digit numbers are there. Means altogether how many numbers are present over here, we need to find out. For this purpose, we consider the last number 99 as Tn. So Tn is equal to 99. We will suppose, or we can write say, we know Tn is given by a formula a plus n minus 1d. Isn't this? Or Tn is 99, we have supposed, and A is the first term which is 12 plus n minus 1 as it is. D, the common difference is 3. Isn't this? Or 99 minus 12 is equal to 3 and minus 3. Or 99 minus 12 is 87. And this minus 3 will come this side to become plus 3 is equal to 3n. Or it is 90 is equal to 3n. Or 90 divided by 3 is equal to n. Therefore, n is equal to 30. It means there are altogether 30 terms which are divisible by 3 and which are of 2 digits. Is this clear? Okay, then let's go to next question. Question number 5. How many 3-digit natural numbers are divisible by 7? So solution. Can you tell me what is the first 3-digit number? It is 100. What is the last 3-digit number? 99. Sorry, 999. Isn't that? It is 999. Now, question has said to take only those 3-digit numbers which are divisible by 7. Is 100 divisible by 7? No. 101? No. So if you keep on finding, you will find that the first three-digit number which is divisible by 7 is 105. And then the next number will be 112 and so on. Similarly, if you start from last, is 999 divisible by 7? No. Then what is a number which is divisible by 7 from last? Can you guess? You can calculate and you will find that the last number is 994. Isn't this? Okay. So the list of three digit numbers which are divisible by 7 is 105, 112, 119, so on till 994. Isn't this? And if you observe carefully, this will form an AP where the common difference is 7. So we can write which forms an AP where the first term A is 105, common difference D is 100, it is 112 minus 105, which is equal to 7. We'll suppose let Tn is equal to the last term 994. This is the last term. We need to find out the number of terms present over there. So we know Tn is equal to A plus n minus 1 D, or Tn we have supposed 994 equal to A. A means first term, it is 105 plus n minus 1 is not known to us, and D, the common difference is 7. Now we will solve this equation to get the value of n. So it is 994 minus 105 equal to 7n minus 7. Isn't this? Or it is 8, 8, 9. Isn't that? Equal to 7n minus 7. Or 8, 8, 9 plus 7 is equal to 7n. Or how much is 8, 8, 9 plus 7? It is 8, 9, 6 equal to 7n. Or 8, 9, 6 divided by 7 is equal to n. So how much will you get the value of n on dividing? Let's try. It is 7 ones are 7 twos are 14 and 7 eights are 56. Isn't that? So ultimately n is equal to 128. So therefore there are altogether 128 terms which are divisible by 7 and which are of 3 digits. Is this clear? Okay. Now let's go to next question. Question number 6. Find the number of natural numbers between 101 and 999 which are divisible by both 2 and 5. Okay. Let's assume we have 20. Is 20 divisible by 2? Yes. Is 20 divisible by 5? Yes. Isn't 20 divisible by 10 as well? Of course, 20 is divisible by 10 as well. Let's take one more example, 40. Is 40 divisible by 2? Yes. Is 40 divisible by 5? Yes. Is 40 divisible by 10? Yes, of course, 40 is divisible by 10 as well. So keep in mind, any number which is divisible by both 2 and 5. Both 2 and 5 is also divisible by 10. Is this clear? I repeat, 2 and 5, not 2 or 5. Please keep in mind, there is a lot of difference between 2 and 5 and 2 or 5. They have different meaning. In our question, it is 2 and 5. So a number which is divisible by both 2 and 5 is also divisible by 10. Okay. So let's go to our question. Solution. We have to find natural numbers between 101 and 999, which are both divisible by 2 and 5. Means indirectly, which are both divisible by 10. Isn't this? So what is the first number which is divisible by 10? It is 110, and then 120. So in this manner you will go, and at last the last number will be 990. Isn't that? So we can write the numbers between 101 and 999, which are divisible by both 2 and 5, are 110, 120, 130, till 990. So if you observe these will form an AP. So which is an AP, where the first term A is 110, common difference D is 120 minus 110, that is equal to 10. Now we will consider, let Tn is equal to 990. Sorry, it is 990. We have supposed, let. So we know Tn is equal to A plus n minus 1 D. Isn't it? Or Tn, we have supposed 990 equal to A. A is 110 plus n minus 1 is not known to us, and D the common difference is 10. Okay, now, or 990 minus 110 is equal to 10 and minus 10, or on subtraction we are getting here 880. The minus 10 from right hand side will come to left hand side. It is plus 10 equal to 10 and, or it is 890 equal to 10 and, or 890 divided by 10 is equal to n. Therefore, n is equal to 89. So, altogether there are 89 terms between 101 and 999, which are divisible by both 2 and 5. I hope this is clear.